Here is an explanation for the answer to final exam question number 4 in Physics Demystified, 2nd edition. Please refer to page 512 if you have the printed book. You're on a planet, some planet besides Earth, where the gravitational acceleration is 4.50 meters per second squared. That's a little less than half of the gravitational acceleration on the Earth. You stand up on a high cliff and you throw a stone off that cliff towards the slimy green sea. This planet has oceans which are filled with all sorts of microorganisms, making it slimy and green. You may not want to dive off that cliff into that sea unless you like green slime. Anyway, this planet, 4.50 meters per second squared. You hurl a rock off that cliff. Now, it doesn't really matter whether you hurl it straight down or not, but I've drawn this because you wouldn't want to be standing right over the edge of that cliff unless you want to end up in the slimy sea. So you throw it like this. Well, the downward acceleration component will happen to be the same as if you dropped it straight down, whether you throw it out like this in a curve or straight down. The downward component isn't affected by that. You'll learn that in the Advanced Physics Demystified course, which I've also created for your enlightenment. But if you were to drop that stone straight down, how fast will it be going straight down after 1.66 seconds? Well, the mass of the stone is 1.57 kilograms, but as things work out in this particular question, this mass is irrelevant as long as we don't have any air resistance in taking it into account here. As long as we have the stone is tiny enough and dense enough that it overcomes air resistance. This could be 1.57 kilograms, it could be 157 kilograms. It isn't going to matter. Galileo proved that a long time ago. Anyway, so the important thing is this acceleration, 4.50 meters per second squared, and the length of time, 1.66 seconds. How fast is this thing going to be going after 1.66 seconds? All we need to do is multiply that 4.50 meters per second times 1.66 seconds. And when we do that, we get not 7.45, pardon me, 7.47 meters per second. That's how fast the downward speed of this stone will be after 1.66 seconds, assuming the cliff is high enough so that the stone has not yet impacted the slimy sea. And the correct choice here is a non-slimy sea.